Welcome to our soil characterization video. Today we'll be going through many different ways to learn about your soil and what it can tell you about your environment. We will be going through soil types and textures, carbonate availability, soil consistency, a structured drop test, soil stability, and soil nutrient and pH. Let's start with soil types and textures. We are going to use the soil texture triangle to determine our soil type and texture. Let's review the different types. Clay is sticky when moist and produces a light sheen when rubbed with the thumbnail. It forms a strong ball resistant to breaking. Sandy clay is plastic, gritty, and sticky when moist and forms a firm ball. Sandy clay loam has a gritty feel but contains enough clay to form a firm ball. Sandy loam has a moderate infiltration rate, a gritty feel, stains the fingers, forms a ball that can be picked up with the fingers and handled with care without breaking. Loamy sand has a gritty feel, stains the fingers, and forms a weak ball but cannot be handled without breaking. Sand has little resistance to root growth, high infiltration rate, and low availability for water for plants. Clay loam is sticky when moist and produces a slight sheen when rubbed with the thumbnail. Loam may have a slight gritty feel but does not show a fingerprint. Loam will form from a ball that can be handled without breaking. Silty clay is both plastic and sticky when moist and lacks any gritty feel. Silty clay forms a firm ball. Silty clay loam is sticky when moist. Rubbing it with the thumbnail produces a moderate sheen, and it also produces a distinct fingerprint. Silty loam has a floury feel when moist and sticky, but will not ribbon and forms a ball that will tolerate some handling. And silt, when moist, has a floury texture, and when placed between the teeth, it has a gritty feeling. For the experiment portion, you will need a shovel, a bucket, a sifter tray, a jar with a lid, and a permanent marker. To begin the experiment, dig a hole at your site. Fill a bucket with soil from your hole. Next, sift your soil until you have enough to fill about a third of the jar. Once the jar is filled with soil, fill the rest with water, leaving a 1-inch gap at the top for room for mixing. Now shake for 3 minutes so that all the soil is broken up into smaller particles. Allow sit for 1 minute. Since sand is heaviest, it will settle the fastest. Mark the top of the sand layer with a permanent marker. Repeat in 1 hour. Silt should settle next. Then wait 24 hours for the clay to settle, and now draw a line at the top of the clay level. Once marked, measure the distance between each line, including the bottom line and the bottom of the jar. Now it's time for calculation. Soil texture is made up of sand, silt, and clay. Those 3 parts add to make 100%. For our experiment, we measured each in millimeters, but the units don't matter since we will be converting each into a percentage. Let's start our calculations. With Site 1, our sand level was 103, the silt was 102, and the clay was 35. Adding to a total of 240. Now to convert into a percentage, we do the following calculation. Percent sand equals 103 divided by the total, which is 240, times 100%. That equals 43%. Percent silt equals 102 divided by 240 times 100%. That equals 43% as well. Lastly, percent clay equals 35 divided by 240 times 100%. That equals 14. Now it's time to determine your soil type. Using the soil type triangle, draw lines that start at each of your percentages. Your soil type will be where these lines intersect. Repeat with each of your sites. So Site 1 was determined to have loam, Site 2 was determined to have sandy loam, and Site 3 was determined to also have loam. We will now do the carbonate availability test. This test allows you to determine if there are carbonates in your soil in a very simple way. For this test, you will need a bowl, your soil of interest, vinegar, and a measuring cup. Collect a cup of soil from each site of interest. Place the cup of soil into a bowl. Next, pour in half a cup of vinegar into each bowl. If there is bubbling, it means the vinegar has reacted with the carbonates in your soil, and therefore you know the soil has a higher carbonate availability. Soil consistency is a simple visual test. Using the Structure Types page of your Soil Sampling Characteristics flashcard guide, take a handful of soil from a hole dug at your site and compare it to the different types in the key. Is it loose? Does it fall apart? Is it very friable? If the soil crushes easily under gentle pressure but will stick together if pressed again? Is it friable? If the soil crushes easily under gentle to moderate pressure? Next is the Soil Structure Drop Test. This test is used to determine your soil structure and type. You will need a shovel, a meter stick, a tarp, a wooden board or hard flat surface, and your soil. Dig a hole that's 15 centimeters by 15 centimeters by 15 centimeters. Collect a shovel full of soil and drop the soil 3 times from 1 meter above the board. If any clumps remain together, drop them individually. Next, you want to organize the clods on the board from coarsest to finest. Make 3 groups: coarse, medium, and small. Next, match them to the key in your flashcard guide to determine your structure type. Next up is a soil stability test. This test determines the aggregate stability of your soil, meaning how well the structure withstands external forces acting on it. You will need a jar container that is at least 5 inches high, a wire mesh or chicken wire, ideally 1/4 inch wide for the holes, water, a golf ball clump of soil, and a stopwatch. For this test, you want to allow the soil to dry out for 48 hours before performing the test. Place your mesh in the top of your jar so it creates an underwater hanging basket. Place your clump in the basket and start your timer. The water will rush into the pores and break it down. Allow your timer to go for 5 minutes. If your clump fell apart in less than 1 minute, you have poor soil stability. 1 to 5 minutes is good stability, and anything over 5 minutes is excellent soil stability. High stability means better infiltration, roots grow better, and there is less erosion. The last test we're going to do is soil nutrients and pH. We will be testing for nitrogen, phosphorus, and potash, and we will be using a very simple kit. Let's start with pH. Using the green tube, fill with small soil particles until the first line. Add in a green pH capsule and then fill with distilled water to the top line. Shake for a minute and then let sit for another minute to develop. Compare to the pH key to determine your pH. For the next test, fill a jar with 1 part soil and 5 parts water for each site of interest. Allow the mixture to sit for 24 hours. Once the mixture has settled, fill the remaining tubes to the 4th line with the soil-water mixture, carefully avoiding not to disturb the settled soil portion. Mix in the corresponding colored capsule. Nitrogen is purple, phosphorus is blue, and potash is red. Then cap the tubes and shake them vigorously. Let the tubes sit for 10 minutes and then compare them to the plant food chart to determine your level of each nutrient. We have now characterized our soil. We gratefully acknowledge the support of WWF Canada.